Hi everyone. Hello Nicolas. I'm glad to be back with you guys talking about Elastic feature and new products. Today we have the chance to have Nicolas with us, and Nicolas will talk us and explain us the new feature Fleet by Elastic. On my side, I will just take a few minutes to present myself and what we do at Data Essential, my current employer and my current company I work with. So let's get started. My name is Gauthier. I'm working as a senior consultant in a company called Data Essential. You can reach me directly with these two web links, by LinkedIn and by email. The company I work with is Data Essential. Data Essential is basically a Luxembourgish startup founded in 2016. We quickly bring attention for some other IT groups. We are part of the French group Link by Net since 2019 now, and more recently, we are part of Accenture since July 2021. Our goal is to offer a tailor-made solution for a customer. So we try to accompany them on all of their IT projects, from the architecture to the cloud migration, data analytics, and stuff like this. We have a specific value within this company. These values are basically, I'll try to do a quick summary for you guys. So from my point of view, everything's changed very quickly in IT, especially in IT. So we try to keep an open mind. Innovation is key to progress, so don't be afraid to experiment and go to more to experiment with cloud-based solution. Transparency in everything is not a break for me; it's an engine. What else should I do? Be always passionate about the work you do. Our mission, as I said, is to accompany our customer to reach their goals. We try to do this in different fields of expertise, consulting and training, coaching, analytics and AI, and we are also a partner with the CNCF, so Cloud Native Computing Foundation. We work based on 4 acceleration paths that are modern architecture, modern infrastructure, modern data platform, analytic and AI, and modern application. So we are here present in Luxembourg to help you reach your goals. We have a couple of keywords on the screen. Feel free to contact us to exchange and see what we can do to help you on these different fields. If you want to contact us, it's very simple. Simply send us an email at sales@dataessential or info@dataessential.com, or just maybe have a quick look on our website. We are also currently hiring. So once again, feel free to drop by our website or LinkedIn pages and send us an email at info@dataessential.com. And that's it for my part. And now it's time to go deep in the real stuff. And I will let the floor to Nicolas, who I'm pretty sure will show us how to properly use the new feature Fleet.
Thank you very much, Gauthier. So welcome everyone. My name is Nicolas. Probably more know me under the handle Ruflin. Over the past 2 years, we worked on that Elastigation and Fleet project. And today I'm going to dive into a bit the technical details behind it. So I'm going to give a very quick overview. I hope most of you already have seen Elastigation and Fleet, so I'm not going to give you a demo on the high-level stuff, but really the technical part. I want to encourage you to actually ask questions directly during the call, so I can jump into the questions, and then I can answer it directly in the context of what I was talking about right now. So please don't hesitate to interrupt. So as I said, my name is Nicola. I'm the tech lead at the data collection team at Elastic inside observability. I'm based in Switzerland, and that's basically it. So let's get to the technical part. The agenda today, we have first a high-level overview over Elastic Agent and the Fleet architecture. It's going to be pretty quick. We dive then first into Fleet, the Kibana plugin. We go to Elastic Agent with Fleet Server. And then in the end, we have some important details I want to mention. Didn't fit in any other topic, but we have it here. And last, of course, the questions that didn't get asked during the call. So let's continue. First, quick architecture overview. So keep that image in mind. I'll take you quickly through it. So we have two Elastic agents, two agents here and one here. The main difference you see is the Fleet server part, but this whole part is responsible around shipping data like logs, metrics, and traces. We have the storage system here, Elasticsearch, of course. We have Fleet, the Kibana plugin that builds the policies, installs some packages, and what that means I get later to it. And then we have an external service called Elastic Package Registry, where kind of information is stored around the whole package mentioned. I get to that. But keep in mind, three major parts: Elastic Agent, one has Fleet Server inside, the Kibana with Fleet, and the Elasticsearch. You'll see that image later on again. So Fleet, here we go. We talk about Fleet and the components it contains. So as I said, looking at the overall architecture, we now really talk about Fleet and the Kibana part, which is a plugin. And Fleet itself basically consists of three parts. The one part, which we don't dive into details today, is the package manager. We see that here. The package manager is the thing that connects to that package registry. And packages, you'll see that in the UI's integrations, is basically there's an Nginx package, a MySQL package. So with one click, you install all the assets and configuration you need for Elastic Agent to collect, for example, log files, to process them, to visualize them. If you use Beats before, you probably think of that as modules. So that is the package manager. The second part is the policy builder. It's where you go in the UI, you put in the log files you want to collect, how they should be processed, and all these kind of things. So I keep saying UI. I'll show you pictures, but keep in mind for all this functionality is always an API team. It's all API based. So the UI is nicer to show, but of course, if you want to use it with some scripts, there's an API inside Kibana that you can use all this functionality to. And then there's the last part, managing the Elastic agents. There is no box in here for that, but basically it's that part that knows how are the agents doing, did the agent receive the new policy, and the monitoring logging around it. So this is really the Fleet part. And now I dive a bit on how these parts store their data. So Fleet itself, of course, it has some states. What is the state of the agents? What is the state of actually a policy? So for all this data, Fleet uses Kibana saved objects. So Kibana saved objects in the end are just documents in Elasticsearch, but it's a format that is supported across Kibana. In these state objects, as I said, you have the state, you have actually what packages are installed, what versions, which assets. You have all the policy builder data, like the configuration you built with all your variables inside, and of course, some user settings. User settings can be the Elasticsearch output, the Fleet URL, which are specific for all the, which are generic and for all the policies. So that's all saved objects, and you should never have to interact with these directly. Then there's the part around the package that are installed. And there are two parts. Parts get installed into Kibana, parts into Elasticsearch. All the Kibana parts are, again, saved objects. You've seen that as a dashboard, as a visualization, as a saved search. That's stored in Kibana, indirectly Elasticsearch. And then there's the other part, ingest pipelines, templates, transforms. These are directly shipped to Elasticsearch and persisted there, but with a predefined naming scheme. So today you cannot easily extend these. We work on a mechanism to extend these so that basically when you follow the convention, you can add your own assets and it's just going to work. And now we get to in this context, the most important part. How do Fleet and actually the Elastigation communicate with each other? And when we quickly go back to this slide here, you see Elasticsearch is actually where all the dots connect. So there is a system indices. There are system indices. We call them .fleet indices. Actually, Fleet star. There are about 6 or 7 indices. I talk about this more detail. But all the data is stored there to basically have a pop-up system. So Fleet can store, let's say, a policy update, an action into that index. Elastigation can read in it. An acknowledgement is sent back. So in the end, Fleet knows where it is. So, okay, it shows hidden slides. I'll skip over that. We import the slides into StreamYard. It seems it didn't skip all the skip slides, so sorry about that. So Fleet integrations is basically the page you see here. And each box that you see on here is basically a package. And as soon as you click and hit install, exactly what I described to you before is going to happen. To show these boxes, it communicates to the package registry. It pulls all the information. So these are not stored in Elasticsearch before you install them. It's all from that registry. Only if you hit install, it's there. There is proxy support around it, that in case you have a proxy in place, you can also use it. So quickly on adding an integration, and as I said before, there is an API for that too, but that's when you say, hey, which policy you want to have it, the name, and the path. And as soon as you hit save, it's stored in that .fleet index. In Elasticsearch, it's picked up by the Elastigation and rolled out. Quickly about the permission model. I'll get to that also in the end. So let's talk about Elastigation and how it works behind the scenes. So Elastigation, we talked about the Fleet part before. We have Elasticsearch. And then I have on that diagram 2 Elastigation. Why is that? So there is one very important component. It's the Fleet server. The Fleet server is just another process that run under Elastigation. But to manage the Elastigations, you need one of these Fleet servers at least. So one Elastigation or a few of them have to be started with Fleet server enabled. So in the end, what happens is the Elastigation actually connects to that Fleet server. If it's this Elastigation here, it connects locally, and the Fleet server is the one that talks to Elasticsearch and does all the magic around the communication. So you could get rid of the Elastigation, and that Elastigation here can just do everything that you know about. But as soon as you, of course, have a whole fleet of Elastigations rolled out, you likely only have 1 or 2 of the Fleet servers. So let's go deeper into the Elastigation itself. And the Elastigation itself is, in simplified terms, just a supervisor that runs other binaries. There are 2 types of binaries it runs. There is the beads and the Fleet server. And in theory, it could be any binary you have that actually supports the Elastigation client protocol. So when you see that gRPC communication between the 2, it's through this channel, the config is communicated, the status is communicated. So any binary that supports that, in theory, could be run by Elastigation. The detail is a bit more complex there as we do some signing and we validate if the signature is correct. So you cannot just throw it in and it's going to work. But in theory, it would. And there is one special binary, the endpoint binary. And you see it's kind of outside. And the reason it's outside, so Elastigation is not only to collect observability data, but also security data. And endpoint security hooks into your operating system and kind of protects Elastigation. So if someone comes along and kind of tries to kill or remove Elastigation, endpoint would actually protect it from that to happen. So that's why it's kind of special and it runs a bit outside of Elastigation. we focus today on standard subprocesses. So Elastic Agent itself, you can run it in two different modes. So the one you're used to when you come from Beats is standalone. Like you have a local configuration, and whatever you configure, it's going to periodically check for change in your configuration. If you use input.d, like you had modules.d, it's going to update. If you want to add more log files, other metrics, that's the way you're used to. But the really interesting one we talk about is the manage mode. So basically you have Fleet enabled, you have the Fleet server in place, you use Fleet, all the configuration happens through Fleet. The configuration is retrieved through that check-in we saw before. And actually, as soon as it's confirmed and act to Fleet server, it's going to update a local config, which we call stored YAML, with the current state that you have. But to get there, you of course need to involve your Elastic Agent. So Fleet somehow needs to know about your Elastic Agent, and normally that happens through a command. You see that on the right bottom side. You get an enrollment command. Your agent is going to be installed, and you actually get an enrollment token. So all you need for that is actually you need to tell the Elastic Agent where Fleet server is, and you need to have a valid enrollment token. So the enrollment happens as following. So first, as said, you need the Fleet server host and the enrollment key. As soon as you give that enrollment key, when you think of the enrollment key, it is actually an Elasticsearch API key with no permissions at all, except enrollment. And of course, through the enrollment, we see you get more permissions. But the first thing Fleet server is going to do, it's going to check, is that a valid enrollment key? You can use that same enrollment key for many agents. But of course, as soon as you invalidate it, you cannot enroll any future Elastic agents with that key. And then if Fleet server says that's all healthy, it's going to create two API keys. One is to authenticate against Fleet server. And again, that's kind of an API key with no permissions from perspective of Elasticsearch. And then there's a data ingestion key for Elasticsearch. That's the API key under which the data is shipped to Elasticsearch. And for security reason, actually each Elastic agent has its own Fleet server authentication API key and data ingestion key. And it goes further. The data ingestion API key actually only has the permissions, the minimal permission it needs to ship data. So if you update a policy and let's say you collected Nginx logs, and now you're going to collect MySQL logs too, and it goes actually to a different data stream, the API key is going to be exchanged. You get a new one with this additional permission or reduced permission. So basically, the API keys get changed pretty frequently, and it's all done for you. So as soon as the Elastic agent receives these three API keys from Fleet server in a policy, it's going to check in to Fleet server, says, hey, yeah, I'm good. Any policy change is received through Fleet server, so it checks in. We have a long polling, which is the default about 5 minutes. As soon as it gets a config, it takes it, acknowledges again that it got it. And then Elastic Agent basically has a pure YAML file. So what it's going to do with it, it goes through it. It has a list of inputs it needs to run. And there's kind of like a lookup table inside Elastic Agent where it says, okay, input log collection is in beats, is in file beat. Metric collection is in metric beat. Like based on the input you run, it could also run audit beat or packet beat. So it knows which subprocess to start and the subprocess today ship directly to Elasticsearch. That's actually something we work on. And this kind of a problem we have currently, every single subprocess ships data directly to Elasticsearch instead of having kind of a combined connection. So I think I missed a few of the questions. David, can you quickly help me out? How can I connect with you personally? In general, I have LinkedIn. You're going to find Ruflin there. So if you Google my name, Ruflin, Nicolas Ruflin, you're actually going to find all my profiles. So the next question is, I want to log logs writing data streams. I use the migrate API, but logs writing again indices. I'm not sure which migrate API you're talking about, probably in Elasticsearch. I don't know the details there. So maybe let's take that question at the end. I think it doesn't attach directly to that part yet, but happy to dive into it. Oh, I should show fleet server config and endpoint config. I'll see if I can do that ad hoc. I don't have any configs prepared at the moment, but we can definitely dive into that. Maybe Skywalker, another option there is also to actually show configs and figure out the problem is jump on discuss. That should also be easy. So in discuss, we can directly share the policy and see and the log files on what went wrong. Thanks, David. That's perfect. So you see the URL there, and there's a whole team that is happy to help you on that one. Okay, so sorry I didn't pay attention in the initial question. I'm going to pay more attention. David, do me a favor, bring it up directly so we can jump in. So back to the slides. So let's talk about a bit the files that you see on the Elastic Agent. There is, of course, the Elastic Agent.yaml file. It's when you run your own Elastic Agent, you manage, I call it on-prem here, but I mean, you can, of course, run it on-prem also when in managed, but you're in control of it. That's where you put your config. As soon as you go actually to Fleet, you're going to see a state YAML that contains kind of the latest state received from Fleet. And you see the Fleet.yaml, it contains some credentials that are needed for Fleet server and the connection there. So I added a few asterisks here because there is a bit of mix between state and Fleet.yaml at the moment, and it's not fully clean. So we actually plan to make some change there. It's going to be, as long as you don't touch these files manually, and you should not touch these files manually if ever possible. It's just going to go through a migration when you go to the next version, but some of the names there might change. So let's talk about the config and the policy we receive, what we do with it. So what we have today is, as soon as the Elastic Agent receives that policy file, and it's all YAML, it's a list of inputs. So Elastic Agent has built in kind of rules, a transpiler with a spec file that knows how to translate an input, a metric beat, CPU input, and a config to actually a config for metric beat. So metric beat itself, unfortunately, doesn't understand the Elastic Agent config. So in that whole spec file, we have many details. I'll get to the question in a second. And so Elastic Agent translates it for the binaries. That's actually something we want to flip around, because Elastic Agent should not have knowledge of all the binaries and how to translate config. So that's why, again, I asked a few asterisks. The idea is really that Elastic Agent just ships down the config. And for example, that's true for APM Server. APM Server supports two different configs, the one in standalone mode for APM Server, when APM Server is run without Elastic Agent, and when it's run by Elastic Agent. So we can get rid of all these translation layers, and each binary can do with it what it needs. So let's get to the question. Is it possible to use Elastic Agent to configure oh no, exactly, something is over the part here. Well, let me check here. Is it possible to use Elastic Agent to configure the heartbeats monitor D rules, to be specific, to use heartbeat for synthetic monitoring? Yes. So actually, Elastic Agent and synthetics is built on Elastic Agent, but you have kind of the monitor D rules there. So I'm not sure what the details there is. I think you mean that directory. So you cannot kind of mix the fleet managed mode and the local mode. You cannot mix these together. It's either or. So, but going back to the question, can you use Elastic Agent and Fleet? And I emphasize on Fleet for synthetics. Yes, that's actually the mainly supported way to use it. Yeah, hope that answers the question. So that's how the config works today. And as I said, it might slightly change, but again, for a user, that should not have any impact. But as I said, it's a technical talk today, so I'll show you all these details. Again, all the configuration, all the communication is gRPC based and encrypted. The feature we have with Elastic Agent is you can upgrade it through Fleet. So basically, you go to Fleet, it's going to show you, hey, you have a newer version of Kibana. That means you could actually use a newer version of Elastic Agent and Fleet of Elastic Agent. So it's going to show you, hey, it's out of date. You click a button, and it's going to upgrade. And behind the scene, what it does, we actually download the binaries from elastic.co. We verify the binaries to make sure we didn't just get any binaries from somewhere else, and we can execute them. We restart us in the end. We restart ourselves. We create a new directory for each version we have. So basically, we can also do a rollback in case things go wrong. And from there, we just run again as before. We pick up where we left. If it's FileBeat, we pick up the state. We check in again to Fleet server, and we just continue to running. So that mode only works when you install Elastic Agent. If you run, for example, Elastic Agent on the Docker, that upgrade feature is disabled. The reason is we expect that if you want to upgrade Elastic Agent, you can upgrade your container. And you don't want to have us kind of modifying your container, and you have a container called Elastic Agent 7.15.2, but actually 7.16.2 is running inside. That feels kind of unexpected, and is why we disabled it. Same is true if you install through RPM or DAP. We're not going to upgrade it for you. You're going to have to upgrade it yourself. So we don't modify kind of your already existing system of managing installations. There is an additional feature in Elastic Agent that is not that widely used yet, but I want to mention because I expect us to use it much more in the future. We call it actions. So we have OS Query Beat, which allows, so OS Query is basically a binary that can run on your machine. It can execute commands like give me the top 5 CPU usage, give me information about the users. Like you can do a lot of things with OS Query. And we have that added to Elastic Agent and Fleet. So basically what you can do now in Fleet, you can type in a command, you want to run, you hit run. It's going to run it on one or many Elastic Agents, and it's going to report that back on the data it collected. So you not only can send down a configuration that is going to run for a long time, you can also send down one in a time action. So in security case, that could also be someone saying, I want to lock down my host, block all external connections, these kind of things. So actions takes the same path through Elasticsearch. It's a special index where we put the actions in. Then basically it defines which agent should get it. Fleet server picks it up, sends it down to Elastic Agents that should receive it, and the Elastic Agents itself report back in the resulting data streams. I expect actions is a feature we're going to use more and more in the future to give you really real-time experience on things you want to execute immediately. Now we go to a completely different topic around configuration. So I'm not going to touch on the basic configuration. It's YAML, it has a list, it has an array. Download Elastic Agent, open the YAML, you'll see it. But there's an interesting part you not directly see is part of the configuration can be dynamic. So you can actually use variables in actually any part of the values. And these variables are substituted by values Elastic Agent reads, for example, from Kubernetes, from the host itself. So that is very powerful, especially in a Kubernetes Docker environment, where you're not going to say, please collect logs from these 3 containers. You're rather going to say, please collect logs from these Nginx containers, or you want to have it for a specific container ID. So you can start playing around with it and build dynamic configurations. Everyone who speaks with Kubernetes and dot discovery kind of already is familiar with that feature. It's an Elastigation, I have to confess, it's not fully built out yet to fully replace the auto discovery, but of course, that's where we're heading. And kind of the dynamic inputs is the foundation for all these parts. So let's talk about debugging. So debugging Elastigation, please go to 7.16. It gets so much easier. So in 7.16, there's actually Elastigation diagnostic collect command. And especially if we get reports about something is not working, the first thing we always do is we look at the policy and we look at the logs. Unfortunately, the logs are not as straightforward in Elastigation as you would hope. So you have the Elastigation logs, but actually each sub-process writes its own log. So many people first look at the Elastigation logs like, there is nothing in there. And we're like, yeah, unfortunately, the problem is in FileBeat, so you need to look at the FileBeat logs. And that diagnostic command is like, you just collect it all at once. But in general, when you debug, be aware there are more sub-directories with logs. There is one caveat with the diagnostics command today. We plan to fix that very soon. It's like it still has credentials inside. So it takes your actually raw policy file and packs it up. So be careful when you share it. Take out the credentials. But we plan to actually obfuscate these and remove them directly in the near future. So, but you might not always want to go directly to the diagnostic command. But first is like you want to know the status. So there are some quite a list of subcommands. I want to show you two today. First one is Elastigation status. It's going to show you the status of all the subprocesses that are running, and of course Elastigation itself. And there's the Elastigation inspect command. What it's going to do is it actually looks at what are the specific configs what do the configs look like for the specific applications or processes we run. And it is kind of attached to the output. That might surprise at first. It makes a bit more sense when you look at the technical part. So because Beats doesn't support multiple outputs, basically when you configure two outputs for Elastigation, it's actually going to run the same beat twice. So you're going to have two instances of FileBeat, and are going to have different configuration. So you, by default, you have a default output. Is in most scenarios that's what you're going to need. You attach the output name, and you get the full output on what that YAML looks like that you just configured, translated to the processes. And in the context of dynamic inputs that I showed you before, it actually also shows you what substitutions were performed. So we talked about Elastigation, and now we go a bit more deeper into that special binary fleet server and what it does and how it works. So fleet server itself is, we cheated here a bit, but it's actually an input. It's run like any other binary. And you can see it in configuration, and it looks similar to this. It has a port and a host you can connect to. It has quite a few configurations around the connections that we plan to simplify. And of course, it also has a connection to Elasticsearch. So when we look at the overview again, going back about 10 slides, remember we had that fleet server here, and that's exactly what we talk about. So these Elastigations communicate with fleet server. If it's local, it communicates here directly on the local host. It's actually even two ports. That's a change that happened recently. So the problem we had is if many Elastigations checked in, or too many, it managed to overload that part, and actually the local Elastigation started to become unhealthy, even though it wasn't. So we actually now have a priority for the local communication between Elastigation and fleet server. There is of course, the self-signed SSL certificate between all the communication channels. So by default, all the communication is encrypted. Now I want to talk a bit about the initial enrollment end. I said it's just an input. Fleet server is quite a bit more than just an input. So what happens during the enrollment is the Elastic agent starts actually a fleet server binary in kind of a bootstrap mode. And it only starts and runs fleet server alone. And then the fleet server push back to Elastic agent an enrollment token through the gRPC communication channel. And at that stage, Elastic agent enrolls itself into fleet server. It restarts fleet server and then comes up and fetches the policy. So I emphasize on that restart. What are you going to see when you actually start Elastic agent with fleet server? You're going to see fleet server booting up, getting killed, and starting up again. And we had quite a few cases where he was like, oh, that looks not right. It is really because fleet server boots up initially in that bootstrap mode, then gets stopped again by Elastic agent because it has everything it needs, and Elastic agent starts it again. So that's where that dual boot up comes from. Skywalker asks around the whole config. As David said before, please use Discuss. Don't send me personal emails with configs to help debug you. That's what we have Elastic and Discuss for. So please keep it there. The reason is everyone can see your problem. Everyone sees the solution. Everyone sees the discussion. Me answering doing private support is not going to help anyone. So here it is, Discuss Elastic CO. There shouldn't be any problem with a 200 character limit there. So that is the whole dance that the fleet server Elastic agent does to be running. So let's talk a bit about the fleet server policy rollout, because in the end, fleet server does a lot of magic behind the scenes you just take for granted. So at first, it all starts in Fleet. Fleet writes to the .fleet policies index, and actually each time it writes, it increments it. And there is a coordinator ID on it, which is always 0 to start with. Then, assuming you have multiple fleet servers, one of the fleet server becomes leader of that policy and is elected. And that leader is then responsible to process that new policy that just came in. What this leader then does, it actually creates out of the existing policy a new revision of it. It adds a new document ID, the revision ID matching to Kibana, and increments it. That kind of indicates it's picked up. And then the fleet server kind of rolls it out to all the Elastic agents. You have that leader for a policy there. If it's a single fleet server, it's very simple. That single fleet server is responsible for all your policies and to do kind of the matching and prepare for Elastic agent. But if there are multiple, one fleet server is going to take it on. If that leader disappears, another one is going to pick it up and be the leader again. So what does that coordinator do? At the moment, not much, but we actually have plans on what further things we could do with it. So talking about the fleet server data in Elasticsearch, Elasticsearch serves of the pub/sub model there. The first one, fleet actions, we talked about this. It's really where these actions are stored. Fleet action results, hopefully also pretty straightforward. We talked about the actions that we had before, and the results of these actions are stored in this index. Fleet agents, Fleet keeps a list of all the agents, what the status is it enrolled, and so on. So that's where that Fleet agents data comes into play. Fleet artifacts, we haven't touched on that on the presentation today, is where there is a special thing that, for example, endpoint uses when you have larger files that need to be sent down to all of the agents. We have that special index that these artifacts are stored in, and through Fleet Server are shipped down to the agents. Then we have an index, of course, with all the enrollment API keys, the ones that you need for Elastic Agents to enroll. You have an index with fleet policies. You have an index with the leader of the fleet policies, we just talked about, and of course, a list of all fleet service. So that's kind of all the data we have and we need to operate the system. So the important details that didn't fit somewhere else, ingest permissions. I touched on that before quickly on the policy part, but I hope now you actually better understand it with data ingestion. So each agent only gets the permission it really needs in Elasticsearch. So you cannot just take an API key from one agent to another agent that tries to ingest different things. That was actually possible with Beats. If you had an API key there, it had kind of all the permission you needed for all the indices. But now with Fleet, we can actually really scale it down to the mil permissions you need. And we actually planned that further. So today you still have some permissions to create dynamic fields. That's basically that Elasticsearch automatically does the mappings for you. And in some cases, that is actually not even needed. So we can even remove these permissions too. The other part is about compatibility, is what is compatible with what. So first, Elasticsearch and Kibana should only be on the same version. Of course, during upgrades, there is a short period that Elasticsearch gets upgraded first and Kibana follows. That's totally fine, but in general, we expect it to be on the same version. The next one is Fleet Server needs to be equal or older than Elasticsearch. So it cannot be newer because we rely on so many core features of Elasticsearch. It could be that in the next version, we rely on a Fleet Server, we rely on more features of Elasticsearch, so not in previous ones. So we require Elasticsearch to be newer. That comes down to Elastic Agent. Elastic Agent needs to be equal or older than Fleet Server. So ideally, you have everything on the newest version, the equal version. Of course, reality does look very different. So it's easily possible you have 714 agents talking to 717 Fleet Server or 716 Fleet Server, and you have a 717 Elasticsearch version. That's all fine. Standalone mode, we get rid of the whole Fleet Server part because you have a policy on your side, which Elastic Agent ships data directly to Elasticsearch. So Elastic Agent needs to be equal or older than Elasticsearch. So that's all the technical slides that I had on my side. I'm happy to dive in some of the questions. I think it gets tricky when we try to discuss policy and debug certain issue. I prefer not to do that in that call, but actually async and discuss. But really concerning technical details and what is behind and why, happy to dive more into.
Let's wait a couple of minutes to see if some questions pops up. Actually, I have a question for you, Nicolas. Just like this, pure theoretically, what is for you the best practice to handle our own policies in Fleet? So imagine I have this particular use case. I will use Fleet to deploy some Metribit to collect some system information on a specific set of servers. And on a couple of these servers, some of them are hosting message queuing layer like RabbitMQ, for example. So what is the best approach for you at Elastic to handle a policy for system and a policy for specific application like MQ, for example, or web server like Nginx or whatever?
Yeah, I assume the discussion kind of question goes in the direction that the RabbitMQ policy should still have all the basic metrics system collection in there. So unfortunately today, what you're going to have to do is you actually create two policies, and you have to manage the system part inside for both and keep it in sync. A discussion we're having is, and we kind of touched on it under the name component policy parts, so that it could actually take certain parts of a policy that you build some components, like in your case, the one around system, and then say, hey, these 3 policies use that component too. So that in the end, you modify it in one place and it applies it to all the policies. We haven't put much effort in that yet, but if that becomes a common problem, we definitely look more into it.
Okay, that's good to know. It's okay.
Kind of question back to you. How do you store these policies today? You have it versioned somewhere, or how do you deal with it today?
To be honest with you, I'm just playing a bit with fleets. So I do not have decided yet what is the best approach to deploy this in production to my customer environment. So I'm trying to see what is the best approach, but I do not decide to do this on a specific way. And for now, I'm using different kind of policies, but that's it.
Yeah. Quickly touching on kind of the API part, I think it ties into that. So as soon as you get many policies, you likely want to have it kind of stored somewhere. So you can, of course, do them that you push policies actually always through the API from your GitHub group. You need to do your own automation at the moment.
Okay.
But there's another part which is interesting in some Kubernetes setups or automated setup. There is a pre-configured API and actually a YAML block inside the Kibana YAML that on boot up, you can actually tell Kibana which policies to put in place. You can even add policies over time to it. What doesn't work is the whole change. So if you change policies inside, it's not necessarily going to remove some parts. But that's another interesting part. If you look at the Kibana YAML, it actually supports a fleet part inside where you can put these there in YAML format. So, and of course, it's in the UI then too, but that's how you can put it there.
Okay, that's good to know. I will try and explore from this. Maybe we can switch question. Yes.
Yeah. So there, Damia has a question around: are there best practices or guidelines to move from legacy Beats architecture to a fleet agent one? We work on these guidelines, so it's not yet as straightforward as we hope. And the reason it's not that straightforward is it really depends on how complex your use case is. For example, if you mainly collect log files, it is much more straightforward to, let's say, go from a file-bit-star index, and there is a data stream naming scheme. Maybe, David, you can put the link in the chat for me. But Elastic Agent follows a kind of a predefined indexing strategy and only uses data streams. So going from kind of these file-bit-star to the data stream naming scheme is, you could deal with aliases there, for example, that you still have the old data because the structure didn't change. You have to package the same processing. But there are other cases where some things change running on the Elastic Agent, that the metrics are called a bit different structure, where it gets more complex. So, Damia, we actually work on a full list on cases. Like if you case A, it's easy. Case B gets more complex. Case C is harder. We work on that. It's not public yet, but yeah, it depends, unfortunately. But there is, if you have very few indices, I mean, kind of not too much different data, look at the data stream naming scheme. I think that's the most important. That's actually not the correct link. Let me put it up in the chat. So data stream is the underlying feature. David, can I comment in the chat? I put it in the private chat so you can put in the public one. But data stream is the underlying, but on top of it, we kind of have log stash, nginx access stash default. And if you could use actually that in Beats today. By default, it writes to file-bit-star, but if you switch it over, it would work. Yeah, here it is. That's the blog post. I'll go in some details there. So Damia, I don't have the perfect answer for you. It depends, but I can guarantee you it's something we heavily work on to get it more seamless.
No more question, guys?
probably discuss is going to be flooded afterwards.
Yeah.
That's okay. That's what it's here for. Yeah, and also if if someone has like more questions afterwards around the technical bits, put it in discuss. Don't ping me on all the discuss topics directly because there is also a team. But yeah, of course, if you don't get attention or you really need the detail relate to that talk, at Ruflin as usual, you'll find me there.
Great. Anyway, thank you very much, Nicolas, for this technical presentation of Fleet and Elastic Agent. It was very interesting. I really enjoyed it. Thank you very much for that.
Thank you very much for having me. Thanks for all the questions.
My pleasure.